Hi, let's try to do the IPv4 network subnetting for this Part C network. So again, before we begin, we notice in the question we are given the network address 192.168.10.0/24. So we are going to apply subnetting to this network. So before we begin, we notice there are actually three routers in this network: R1, R2 and R3. Okay, so what we need to do is we are going to find out the number of subnets. So in this case, let's draw a purple bubble over here to represent the first subnet, another bubble in green for the second subnet, the third bubble in yellow for the third subnet, the fourth bubble in red for the fourth subnet, the fifth bubble in blue for the fifth subnet, and the last bubble, okay, we use purple again for the last subnet. So in this question we actually require a total of 1, 2, 3, 4, 5, 6, minimum of 6 subnets. So let's write that down in the question over here. We need a total of 6 subnets at least for this network. Okay, so let's highlight the network address as well in this case. So next we're going to answer the question on how many bits are we going to borrow in order to create the number of subnets. Okay, so in order to create the number of subnets, we notice that we have a total of 6 subnets needed. Okay, we need to have a total of 6 subnets. So let's try to use the formula we have to determine the number of bits required. So the formula we have noticed is actually 2 to the power of n, okay, where n is the number of subnet bits. Okay, so let's try to see how we can get total of 6 subnets. So in this case, if we let 2 to the power of 1, we will get 2. So we can only support 2 subnets in this case if we have only 1 subnet bit, which is not enough. Okay, this is less than 6. So let's continue. If we have 2 to the power of 2, which is equals to 4, again it is still not enough because it is less than the 6 subnets that we need. So let's try 2 to the power of 3. Okay, so 2 to the power of 3 is 8, which is greater than 6 subnets. So definitely we can use the n equals to 3, where this number of 3 subnet bits in this case. So the number of subnet bits for this question is actually 3. Okay, so let's try to find the answer for the next part C. How many usable host addresses we can have per subnet in this addressing scheme. So in this case, let's try to see the number of usable host addresses. So we now know that we can use 3 subnet bits for the IPv4 address. So in this case, we know our subnet mask is actually equals to 255.255.255. What is the last number? We're not sure. So let's break this down again into the separate binary bits. Okay, so we know that we are going to borrow 3 subnet bits, so let's represent them by the n in blue, and we represent the rest of the bits in red for hosts. Okay, so now we know that we can actually have total of 5 bits for the hosts. Okay, so how do we know how many subnets, how many hosts we can support for this network? To find out the number of usable host address for this network, we need to use the formula 2 to the power of h minus 2. Okay, in this case h is actually equals to 5 bits for hosts. So let's put this into the formula. 2 to the power of 5 minus 2 is equals to 32 minus 2, which is equals to 30. So this is the total number of usable hosts per subnet. So let's put this down in the question over here. So number usable host address per subnet is actually 30. Okay, so let's proceed to answer the next part of the question, where the number of subnet mask. In this case, what is the subnet mask for this dotted decimal format? So let's go back to the table over here. So we know that this is our subnet mask, and we going to represent the network bits by 1 in binary, and the host bit we are going to represent by 0. So this is the binary equivalent for the last octet. So how are we going to get the decimal equivalent for this octet over here? What we're going to do is we are going to represent the first one by 128. We're going to represent the second one by 64. We're going to represent the third one by 32. So the decimal version of this binary number is actually, we're going to add up all this. We're going to get 128 plus 64 plus 32, and we're going to get 224. Okay, so the answer is 224. So the final subnet mask for this question over here is actually subnet mask is actually 255.255.255.224. So this is our subnet mask for this question. Let's write that down. 255.224. Okay, so let's try to find the last question, the answer for the last question. How many subnets are available for future use? So in this case, we notice that we only need 6 subnets, but we are actually planning for a total of 8 subnets in this case. Okay, so since we are planning for a total of 8 subnets, we are going to use only 6 subnets. Okay, so we actually have an extra of 2 remaining extra. Okay, 2 remaining extra networks that we are not going to use. So in this case, the answer is 2 for the last part. Future use, 2 subnets available. Okay, so given this information already, we can actually populate the addressing table over here. So let's proceed with the first address given, 192.168.10.0. So in this case, this is the network address. We're going to put this in the subnet address, in this case 0.0. Okay, so the first usable host address will be 192.168.10.1. okay, the last usable host address is actually 192.168.10.1. okay, so to do this, let's go on top and look at our question over here. The number of usable host address per subnet is 30. So the address over here is actually 30. Okay, and the broadcast address will be 192.168.10.31. So that is the address for the first subnet 0. We can proceed to do the next for the subnet 1. It will be the 192.168.10.32. First usable host address 10.33. Last usable host address will be 192.168.10.1. So in this case, we notice that the address over here is 32, and we're going to have a total of 30 subnet addresses. So in this case, this is actually 62. Okay, and the broadcast address will be 192.168 192.168.10.63. So that is the addressing for the subnet 1. So we can continue to proceed for the rest of the subnets. So for this one will be 192.168.10.64, and first usable host address will be 10.65. Last usable host address will be 64 plus 30 in this case. Why 30? Because we have a total of 30 usable host address per subnet. So in this case the answer will be 94. Okay, so in this case the last usable host address is 94. Okay, and we can continue. For broadcast address will be 10.95. Subnet 3, 192.168.10.96. First usable host address 10.97. The last usable host address will be 96 plus 30. Okay, so in this case it will be 126. So that will be 126 over here, 126, and this will be 127. Subnet 4, 128. Network address, first usable host address is 129 to what's the next address is 128 plus 30, which will be 158. Okay, so in this case we have a total of 158, and the last broadcast address will be 159, and so on. Can continue. For 160, the first usable host address will be 161, and the next last usable host address will be 160 plus 30, which will be 190. Okay, so in this case the answer will be 190, and broadcast address will be 191. Okay, for the address for subnet 6 will be 192.193.10.193 to the last usable host address will be, in this case, 192 plus 30, which will be 122. This is 223, and the last address coming up will be 224. For the subnet address, this will be 225. The last usable host address will be 254, and this will be 255. So this is the address for the whole of the network over here. Okay, after we have completed the IP addressing table for this network, we can proceed to fill up the addresses for the network devices in step 3. So what we need to do is we will look at the first device, R1. Okay, for R1, gigabit Ethernet 01. So assuming we have this network over here, okay, so let's try to represent this network by this segment over here, and we're going to copy this, and we're going to copy this paste over here for easy reference. Okay, so what we need to do is we're going to draw the network subnet for this network again. So let's draw the bubble. In this case we have a total of one network over here. The next network is actually this network over here in green. The third network, let's represent it by this red color bubble over here. The fourth network, let's represent it by the orange bubble over here. the fifth network represented by this purple bubble over here, and the last network represented by this gray bubble over here. So we have this total of 6 networks over here. Let's label them by the subnet number. So for example, we call this subnet 0, we call this the subnet 1, let's call this a subnet 2, let's call this subnet 3, we call this subnet 4, 1, 2, 3, oops, and this is subnet 5. Okay, so we have total of 6 subnets: subnet 0, 1, 2, 3, 4, 5. Okay, so let's try to represent the addresses for the interface in these subnets. So what we need to do is we are going to look at the table over here before we can actually subnet the addresses. So let's use the first subnet 0 for the subnet 0 bubble over here. Okay, so notice that for the first R1 gigabit 01 over here, we actually inside the subnet 0. So let's assign any addresses within the subnet 0 for this gigabit Ethernet 01. Okay, so let's take a look at the subnet 0 over here. We have the address range between 192.168.10.1 to 192.168.10.30. so let's assign any addresses within this assigned range over here. So let's give it 192.168.10.1, let's say, any addresses. Okay, and subnet mask will be 255.255.224. okay, so let's continue to look at the next interface for R1 serial Ethernet 000. Okay, so R1, let's take a look at the diagram over here. R1 000 is in subnet 1. So let's take a look at our subnet 1. In this case, our subnet 1 is at this portion over here. Okay, so the available address we can assign is actually within this range, 33 to 62. So let's maybe we can assign the addresses for this 000.1 to 192.168.10.33, any addresses within the range, and the subnet mask will be okay. After we have filled in the IP address for the 000 interface for R1, let's continue to fill up the address for 0001 for R1. Okay, so looking at the diagram over here, for R1, 0001 falls onto subnet 3. Okay, so for subnet 3, we look at the table we have drawn earlier. So for subnet 3, the addresses are in this range, and the addresses we can allocate for the 0001 interface is actually any addresses within this range over here. So let's use the 10.97 address for the 0001. In this case is 192.168.10.97. okay, and the subnet mask will still be the same. Okay, so let's proceed to fill up the addresses for R2. So let's examine R2. In this case, R2 is over here. The first interface we are going to allocate is gigabit Ethernet 01 R2. So G01 of R2 is within subnet 2. So what we're going to do is we're going to look at subnet 2 over here. Subnet 2, range of addresses we can give is actually between this 10.65 to 10.94. So what we need to do is we go over here. We're going to allocate the first address, any addresses within the subnet, and the same subnet mask Okay, so let's examine the next one, 000 for R2. So for R2, 000 is in the subnet 1. So let's take a look at our subnet 1. In this case, we have the subnet 1 range between 192.168.10.33 to 10.62. Okay, but we have already used up the 10.33 earlier, so let's use the next one, 192.168.10.34, and the subnet mask to be the same. Okay, and let's proceed to address the IP address for 0001 for R2. So R2, in this case 001 is in subnet 4. So let's proceed to look at our subnet 4. In this case, subnet 4 is here, and the range of addresses we can give is actually this range of address between 129 and 158. So let's go over to here and let's give it maybe 192.168.10.129. Okay, so any addresses within the range, and the subnet mask will be 255, same subnet mask, and proceed to fill in the rest. Gigabit 01 for R3. R3 in this case is here. Gigabit 01 is in subnet 5. So let's proceed to look at subnet 5. Subnet 5, the range of addresses between 161 to 190. So let's give it the 192.168.10.161, and the subnet mask will be the same. Okay, and for 0000 for R3, 000 is in subnet 3. So what we need to do is we look at subnet 3. Again, subnet 3 we have used up the first one, 97. So we are going to use the next address, 98 instead. 92.168.10.98 and 255.255.224 for this address. For 0001, in this case 0001 of the R3 is in subnet 4. So subnet 4 is the range of address in over here between 129 and 158. So let's put it to 192.168.10.130 to 255.255.224. Okay, we are almost done for this long question over here. So let's try to answer the last part B for this question. So the next part is we are going to fill in the IP addresses and subnet mask for the devices. Okay, so devices, in this case we have our PC, our switches, and so on. Okay, so let's try to allocate the addresses based on the subnet that we have already drawn up so far. So let's take a look at our PCA. In this case, our PCA falls under subnet 0. So let's go on to our subnet 0 over top. So on the subnet 0, our range is between 192.168.10.1 to 10.30. So in order to avoid any confusion between the allocated addresses, let's use the last available address. So in this case, let's use 30 for the PCA 192.168.10.30 for the PCA. Subnet mask is still the same. 4. Okay, we'll leave the default gateway in a short while, and PCB will be the next address, 192.168.10.31. Okay, subnet mask is still the same. The part on switch 1. Okay, so let's take a look at switch 1. So in this case, our switch 1 also falls in the same subnet 0. So let's allocate an address over there for switch 1, VLAN 1, 10. oops, I'm sorry, this is not 31, should be 29, and this is 28, and the same subnet mask. Okay, so that's done for PCA, PCB, and switch 1. We continue with PCC, PCD, and switch 2. So let's take a look at the diagram. PCC, PCD, and switch 2 are in subnet 2. So let's take a look at our subnet 2 over here. So for subnet 2, the range of addresses is between 10.65 to 10.94. So let's use the last address again for easier allocation. 10.94, right? 10.94, yes. So let's use the last address, 192.168.10.94, 255.255.224, 192.168.10.93, 255.255.224, and the switch 2 is also in the same subnet 2. Okay, so let's use the next address, 92.168.10.92 and 255.255.224. Okay, so that's done for PCC, PCD, and S2. So let's take a look at the last 3 devices, PCE, PCF, and S3. So PCE, PCF, and S3 are in subnet 5. So let's go on to subnet 5 over here. So subnet 5 range of addresses is between 192.168.10.161 to 190. So let's use the last address for this PCE, 192.168.10.190. Subnet mask is the same, 192.168.10.189, 255.255.224, and the last S3 is 192.168.10.188 to 255.255.255.224. Okay, so that is the IP addresses and subnet masks for the devices. Okay, so let's take a look at the very last part on the default gateway for this subnet. Okay, so in this case, how do we define what we call the default gateway? What exactly is our default gateway? Okay, so we can see the default gateway better by looking at our network diagram. So in this case, this is our network diagram we drawn earlier. So the default gateway is actually the device that we actually have in the center of the network. So in this case, let's look at the subnet 0. So for subnet 0, our default gateway is actually R1. Why is that so? If you look at this subnet 0 over here, the entrance to the subnet 0 or the exit to the subnet 0 is actually R1. So R1 is acting as a gatekeeper for this subnet 0. Okay, so this R1 is the gatekeeper, or sometimes the technical term is actually called the default gateway for this subnet. Okay, so in this case, R1 is the default gateway for this subnet. And how do we know which interface do they actually exit? In this case, the default gateway for subnet 0 is this G01 over here. Okay, so this is the default gateway, the interface to exit from subnet 0. So let's go to the table earlier, look for our G01 for R1. So R1 G01 is over here, so our default gateway is actually this address over here, 10.1. So this is our default gateway for the first subnet. All of them have the same default gateway. Okay, so let's examine the default gateway for PCC, PCD, and S2. So for PCC, PCD, and S2, the default gateway is through R2, and the interface is actually G01 also of R2. So let's take a look at our G01 of R2. In this case, G01 of R2 is actually this address over here, 192.168.10.65. So in this case, let's put this as our default gateway. And the last default gateway for PCE, PCF, and S3. PCE, PCF, and S3 default gateway is actually G01 for R3. So let's take a look at our G01 for R3. In this case, G01 for R3 is 10.161. So this is our default gateway address for the R3 subnet. Okay, so that's the answer for the IP address, subnet mask, and default gateway for the 3 subnets.